Hello everyone, this is Mohammed Nashat and welcome to this brand new YouTube channel. And I'm super excited to share one of my machine learning projects I have done recently. In this video, we are going to build a convolutional neural network using Python, Tensorflow, Keras, and more. What excites me the most is the dataset I have created for this project. These datasets consist only of my friends. I have selected a few of my friends and gathered them all the photos and combined them into a dataset. So without talking much, let's dive into action. These are the images of my friends which have been collected and saved in my gallery. Out of these images, I have selected 140 images per each where their faces are clearly visible and can be cropped out. After cropping the images, what we do is resize and rename. We have to resize it to a certain resolution and then we need to rename all these files. As we see, these folders contain the cropped images, Nadi, Nazif and Rizni. Each and every folder has 140 images. Now we create separate folders for saving the resized images. Each and every image will be saved into 224 into 224 resolution. Here the Anaconda Navigator comes. Simply go to the apps menu and launch the Anaconda Navigator. It will load for some time. This is the main interface of the Anaconda Navigator. Here we see what the available options here. This is the notebook in the version of 6.5.4 and that one is Jupyter Lab, and this is the main important thing in the Anaconda Navigator is the environment. Okay, there are some environments available. One of the advantages is we can create any kind of environments with any kind of packages within it. Current environment is the base. There are some other environments also available like CNN environment, gesture recognition, IIS and so many things. Okay. In the base environment, if we look, so there are some packages. We have to install several packages in the environment and to manipulate the files we need. Okay, let's switch to the CNN environment where I have installed all the necessary packages to be done for this project. If you look at the CNN environment, the NumPy version has been changed from the base variant. Let's type TensorFlow. Okay, the current version is 2.16.2. Okay, also the Jupyter Notebook version is also changed here, 7.4.4. if you go to the base variant, the TensorFlow version has changed as well as the Jupyter Notebook version also changed. So let's go back to the CNN environment. Okay, these are the installed packages right here in the CNN environment. I have put all the names of the packages this project in the video description. Let's launch the Jupyter Notebook. And one more thing, you can select a specific version of Jupyter Notebook as per your need. Up to now 7.4.4 is stable and I have worked several projects before, so it is stable. We simply click launch and it will load for a while, and here is the tree. Okay, from here we have to navigate to the file path. Where are we going to train the model, where are we going to put our data sources and the desktop and face project. Here is the path we have created. In here we click the Python 3 IPy it will create a notebook file IPynb, and if we need to install any kind of packages here, we just simply click the terminal, and up to now we don't need, so we click the Python 3 IPy. Okay, the kernel is loading and it is loaded. First of all, let's rename the notebook file. Okay, now we have to import PIL, Python image library. Okay, this PIL is imported from Anaconda Navigator and it should be Pillow. Pillow should be installed. The next one is the core OS functions, import OS. Next we define the input folder, the output folder and the target size. Here is the input folder, Nadi cropped. We can get the name from the file and just paste it here, Nadi cropped. The output folder should be Nadi resized or resized Nadi, something like that. We can rename as per the other persons. Here is the target size. The target size should be a Python tuple consisting of 224 into 224 image size. This OS function make this output folder exist okay equal true will create the folder as in the output folder structure. If it has already created such folder, it won't create any issues. These images will be saved within that folder. Now let's create the loop structure for iterating through all the files in that folder. To do that, we give the Python for structure just like that. For x in range, within the parentheses we give the folder, we give the number we need to iterate. Just like that for file name in OS list here input folder. So all the files in the input folder should be iterated. The next one is if file name lower ends with png, we give the image formats like extensions png, jpg, jpeg. These are the basic iterations. If not, this will ignore that file. Great, now we have created the loop structure, we have created the filtering if condition, and then we create the image path. It goes for the full path to construct the image file to be read through this structure. And then next we create the image.open which will use the pill option to open the image, and then it will convert into RGB, which will be a standard option to do these kind of image manipulations. Another one is the next line is the image resize, target size resampling lang source. So we use the lang source method to resize the image into 224 into 224 as we already mentioned there. And finally the line for saving the edited images or the cropped images into the respective directories. In this case, resize Nadi. There is an error. Fine. Python true and false should be start with capital letters. Here we go. The Nadi resized folder has been created and all the images have been saved. And if you look, the image is been resized into 224 into 224. Let's check get info, and the dimension is 224 into 224. Okay, success. Let's check another one. Yes, all the images are saved in 224 into 224 and the color space is RGB. Let's select this code and rename it as Nazif. Also for Rizni. These are the 3 persons we are doing in this project. So we have to do this code for each and every person. Let's check. Okay. All these files, all these folders are created. Let's rename the notebook file again, resize and rename -nb. As we already imported the OS, we don't need to do that again. We do the rename parts here. The folder path should be the same, Nadi resized. Again, we're going to give the prefix Nadi. The prefix will act as the new name for the file. Here is the image files sort. The sort will arrange all the images in the alphabetical order. So again we are using that os.listdir folder, listdir function, which is the Python OS module which will get all the files within that specific directory. And again we are doing that ends with jpg and jpeg, png. We are only taking files which are only have these kind of extensions. Otherwise it will ignore that files. What next we are going to do is the for loop for renaming all the files. Now we are going to loop through the files within that folder Nadi resized. That's why we use enumerate in here for I file name in enumerate, which will act as the loop structure. Within the loop, the first line is going to split the extensions in that file, original extensions, os.path split text, which will split the text as the extension. So the new name we are going to print here contains 3 parts. The first one is the prefix. The prefix we got from we mentioned already. The second one is the loop number 1, 2, 3, and the 3 means here, the 3 which have been mentioned here is the digits we are going to show. 0, 3 means we are going to show that in 3 digits. The third one is the extension. Then we have to give the source and the destination folders. The source is the OS path join folder name. As the folder name, as the folder path, we have already given the resized, and the file name. The file names are being created within that loop. And the destination is also the same, OS path join folder path, and the new name. And the new name we will give. It will rename according to that source and the destination. Finally, we are using another Python OS module, os.rename, the source and the destination. After doing the loop, it will return a message, success. And one more important thing we have to consider, we are working within one folder, phase project. So we are keeping all the files, all the folders, notebook files, data sources, everything within one folder. So we don't need to give the file paths. If you are working within 2 directories or 2 folders, we have to explicitly give the file paths. Let's see what happens. Before that, we have made a mistake here. The destination file should contain the new name, not the file name, because the new name only contains the prefix and the orders and the extension as we have mentioned within that loop. So I think now it will return the correct values. Now the code looks good, and we copy that code and paste it, so it will return Nazif 001, Nazif 002, like that. Also, we are going to do for the third person. If you look that, the images are renamed according to the structure we have defined within that loop. Now we create a new folder named data.dir or data directory something, and paste that 3 new folders, Nadi, Resize, Nazif, Rizni, into that folder, as well as we have to move that unmatched class as well into that folder. Let's create a new notebook, model train, and let's import all the necessaries. Okay, the first one is import TensorFlow, and we know TensorFlow is the Google machine learning framework, and within TensorFlow we import keras. In the keras we import models. We import the sequential models. Sequential is the model for stacking the layers in linear format one after another. The model we are going to train is sequential. After importing that, we need to import the layers, as the model contains so many layers, hidden layers, input layer, output layers. So in that layers, we import some layers. The first one is the Con2D. Con2D is the 2D convolutional operation. As we know, we are doing the project as the convolutional neural network. There are some neural network available like feed-forward neural network, recurrent neural network, and convolutional neural network. And this one is the convolutional. So we import Con2D. The another one is the max pooling 2D. Max pooling 2D acts as the maximum pool size. It will restrict the maximum pool size to restrict the input size. So it will help to reduce the model size, the input size. Another one is the flatten. Flatten is used to convert the multidimensional arrays or multidimensional layers or inputs to 1D vector. So if we input images as the 2D format, it will convert the 2D images into 1D vector. Another one is dense. Dense is the connector. Dense connect the neurons within each layer forward and backward, input neuron to output neuron. The last keras layer we are going to import is dropout. Dropout randomly drops some inputs to prevent overfitting. Let's import ImageDataGenerator. It will act as some pre-processing techniques to the images we are inputting through the model. Then we install TensorFlow, keras, callbacks, import EarlyStopping. We know there's a high risk of getting the model overfitting, so in order to prevent that, we import that. And finally, we import NumPy SNP to manipulate with numbers, and then the core OS functions. Let's run the code snippet, and it takes a while, and okay, it's loaded. Okay, there is an error. Okay, Con2D. Fine, now it's worked. Okay, now let's define the data paths and parameters. The data dir and then the image size, as we already mentioned, 224 into 224 image size, and the batch size we give 16 for a smooth input of the neurons. And there are 4 classes: Nazif, Nadi, Rizni, and the unknown class. Okay, there are 3 epochs, and we have mentioned the basic functionalities of the model. We forgot to include the test drive directory. So test dir equal to, let's include the path. We have to create a test data set which will be validating the end value of our model, end performance of our model. So let's copy the path and paste it. For an alternate, we can divide their entire data set into train, test and validation, but this is the best practice. Training and validation into a data set and testing into another data set. Next, we pre-process the image data. Here we use the ImageDataGenerator module, and there are some metrics: rescale, rotation range, brightness range, validation split, and so many. So these values for the metrics may change according to the image data set we have. After pre-processing the train data gen, let's work on test data gen. Now we have to create three generators: train generator, validation generator and test generator. Three of them should be alike but not the same, exact same. So the first train generator, flow from directory is the method from directly getting the data, image data from the file directory, and data directory we have already mentioned. The target size is image size. We have already mentioned the image size as 224 into 224. The classes might be numerical or categorical. As we're doing a multi-class classification here, we use categorical. So it will one-hot encode all the image and labels. The next one is subset training. As we know, we have divided the entire training data set into training and validation. Training 85%, testing 15%. Let's copy the code and paste here. Now the second one is the validation generator, and train data gen, and the subset is validation. Okay, we forgot to mention the batch size. Already mentioned the batch size previous, so batch size is 16 and the batch size. Here we also mentioned the batch size in the validation generator. Okay, the next one we are going to do is test generator. Test generator, we don't need the subset part. We have to change the directory into test directory. So let's copy the test directory and paste there. And we don't need the subset validation here because there is the only class. We turn off the shuffle here because we use the testing data in a consistent order. The output is 470 images for training, 84 for validation and 32 images for testing. Let's define the CNN architecture. Okay, here we use sequential model, we already mentioned there, and we are going to use Con2D, max pooling and dense and dropout are the layers. The first stack of layers is the Con2D, and we are getting 32 filters with 3x3 sizes. To feed throughout the Con2D layer, we have to mention the input shape. As we know, we are inputting 224 into 224 images with 3 color channels RGB. This is our first max pooling 2D layer. This is 2 into 2 pixels. This will reduce the spatial dimension into half. This is the second Con2D layer, consists of 64 filters in the size of 3 into 3 filter size. It will gain more complex patterns in the image. Here also we use the relief activation function as the hidden layer and the second max pooling 2D layer with the same size of 2 into 2. Next we use flatten. It will convert the 2D or 3D multidimensional arrays into 1D vector. Then we stack a hidden dense layer with 128 neurons and an activation function of ReLU. As we are dealing with a smaller model, we have a higher risk of getting our model overfitted. So in order to avoid that, we use the dropout function. And finally, we stack the output layer, the dense, with the activation function of softmax. The softmax will give the output as the probability function, out of 100, out of 1 in percentage. To sum up, the first set of Con2D and max pooling layers will get the low features in the images, like the edges. The second set of Con2D and max pooling will get the high features in the images. After defining the model, we have to compile the model with parameters. The first parameter is the optimizer, and there are many optimizers available: stochastic gradient descent, RMS prop, and we use the Adam. That is the latest and the most efficient optimizer for this kind of projects. And we are mentioning the learning rate as 0.001, that is the default value of Adam optimizer, and we can change the learning rate based on the performance of our model. For better learning, we have to mention the loss function. we can use categorical cross entropy because we use multi-class classification where the labels are one-hot encoded. To evaluate the model while training and testing, we use metrics. There are many metrics available: accuracy, precision, recall, and so many there. Here we use only accuracy and precision. Before getting our model exposed to data, we can see what are the inputs, what are the outputs, and what are the layers using model.summary function. Here we have made a mistake, and the rotation range should be 10, not 0.1, and we can add another matrix, zoom range is equal to 0.1, and the horizontal flip is true. It will enable the image to flip over. We can simply press shift plus enter to run the current cell and go to the next cell. And finally we have reached the training phase. Let's get our model run, play with the datasets we have created, and learn by itself. Earlier we have defined all the metrics, values, and functions. What we do is just run them. This is the EarlyStopping we have imported from the Tensorflow Keras callbacks. If the model doesn't improve over epochs, or if start overfitting, it will immediately stop the training process. The EarlyStopping monitor we have given is the validation loss. If the validation loss does not decrease after epochs, the model will stop training. The patience is 5, which means it will continue 5 epochs after the last improvement in the validation loss. And we have given the restore best weights as true. So it will not get the value from the final epoch, but it will get the best epoch with the lowest validation loss in the training. Okay, let's fit the model. The history will save the training metrics. The first one is train generator. We have already mentioned train gen 476 images with 4 classes. Also we have mentioned the epochs. In the validation data we have split from the dataset, and the callbacks is EarlyStopping. That one is also we have mentioned above. So let's run the model. Validation generator. Right, the model is started training. The warning messages here is based on my computer. It might change, or the warning message doesn't come based on your computers. As we see, the training loss has significantly improved from 12 to 1, which means our model is upgrading its weights and learning. Okay, I'll fast forward the training process and let's see what happened at the end. Okay, the model has stopped after the 26th epoch. And let's decode what happened. If you see at each epoch, the first 3 metrics are the training metrics. The accuracy, loss, and the precision are the training accuracy, training loss, and training precision. And the second one is the validation accuracy, validation loss, and validation precision. The accuracy means the proportion of correctly classified images, and the loss is the difference between the actual labels and the predicted labels. Precision is the average accuracy across the 4 classes. Let's discuss the observations we have gained from these epochs. The first epoch has the lowest accuracy and the highest epoch of the entire training epochs. And over the epochs, it has gradually improved. The model has been gradually improved. Slowly and steadily, the model has been adapting and changing its weights to get the higher validation and training accuracy, and also to reduce the losses. At the 10th epoch, the model has achieved a significant improvement, the training and the validation accuracy around 0.85, which is a good sign. After that, we can notice the training process has got a little of fluctuation. The metrics are not going too high, not going too low. Just adjusting its weights, and the accuracy and the loss are getting up and down in a little bit of amount. At the 21st epoch, the model has achieved its best, its peak, with a validation loss of 0.0826. After the 21st epoch, the validation loss is gradually going high. So the model will automatically stop its training process after 5 waiting epochs. So the model has stopped at 26th epoch with the validation loss of 0.0920. But the model will take the best value, as we have mentioned the restore best value. So the model will take the 21st epoch as the best with the validation loss of 0.826 and the accuracy, training accuracy of 0.9024 and the validation accuracy of 0.9762, which is the best that the model has achieved. After completing the training of our model, we have achieved a significant accuracy. Now let's expose our model to the test dataset, which the model has not seen up to this entire time. So already we have divided the entire dataset into training and testing sets. Now let's expose the testing set into the model, and this accuracy is the actual accuracy of our model, the test accuracy. The metrics we have given here is test loss, test accuracy, and the test precision. We have mentioned model.fit at the training, and now we have mentioning the model.evaluate with the test generator, with the test data set we have created. And the second line is the print function of printing the accuracy and the precision. This is what we expected. The test accuracy changed to 0.7812. The training accuracy we have achieved is around 0.97, and the test accuracy is 0.78. Because we have comparatively a smaller data set, the test accuracy is somewhat acceptable. If we decode the test accuracy, around 78% of the testing images were identified correctly by our model. Another metrics we have to consider, the loss is 1.66, which is a bad sign for our model. But as we have a very limited amount of data and the training and the testing data set is really low, only have 48 images, even a single miscalculation will create the loss higher amount. So what we have achieved here is 0.78 test accuracy and a precision of 0.78. Let's save the model as Keras or H5 format. And the model has been saved into our project directory. And now we can load this model for the future use. Model equal Tensorflow, Keras, model, load, and then the name of our model. And the model is now loaded successfully. Also, as I told earlier, we can save as H5 format, but the Keras is the latest method to save. Okay, if you save, it will automatically show you a warning notification. Okay, now two models are saved. Now what we are going to do is test our model with some unseen images, real images. To do that, what we need is some unseen images for the 4 of our classes, Nazif, Nadi, Rizni, and unknown images. We get some additional images and load them into a new directory, unseen directory, and then load each and every image and get whether our model is predicting correctly or not. In the unseen directory, there are 8 images. The first one belongs to class Nadi, the second one belongs to class Nazif, and the third one belongs to class Rizni. Fourth one is again class Nadi, and the next 4 of them are other people which can be added to the unknown classes, the test 5, test 6, 7 and 8. Let's check whether our model is predicting the models or classifying the images into the correct classes. We copy the path of test 1 image and paste it here. The first one is predicted successfully. As we already told, this one belongs to class Nadi. And let's put test 2, and this one is also correct, Nazif class. And the third image, test 3, belongs to Rizni, but it has a very low probability, 0.5. If we increase the threshold value, it will mention it's not matching to any person. The first 2 classes are matching with a higher probability, but the last one is very low probability. So this is the area of improvement for our model. And let's check the test 4. This one is also corrected, identified correctly with higher probability. Let's check another image, test 5. Oops, here our model has made a mistake. Here it has predicted an unknown class as Nadi. The reasons might be the model may have overfitted or observed some noises around the data sets, or the unknown class data sets might be not enough to train or to generalize, or maybe there may be some other reasons. So we can come to a conclusion that our model has identified 4 out of 5 unseen images which is around 80% of our model accuracy on unseen data. Great, we have made it. This is the end of the video. To sum up, we have gathered my friends' photos and prepped them, feed them into a CNN network, and then got a 78% of test accuracy and classify them into 4 categories. And I think this video covered most of the parts in the basic parts of CNN, how to create them, how to build them, what are the metrics and what are the parameters and what are the hyperparameters, and how to optimize them in a better way to get some better outputs, and everything that I have known being covered. And since this is my first video, there might be some issues, errors and flaws. Drop a comment in your comment box. That might be positive or negative or somewhat, and I love to have them in my comment box. And please like this video and subscribe to the channel. See you on my next video with some other cool stuffs. Until then, peace, bye.